Welcome to Fuel Your Mind, a web series dealing with all things diesel. On this episode, we talk about engine wear.
A new diesel truck can cost you close to $60,000. Even a used one can still run you $20K. But if you want more power, you want a towing capacity of up to 17 tons, or you just want better fuel mileage, then the cost may be worth it to you. So you take the plunge and you shell out all that extra cash for a new diesel truck. Now that you have all of that money invested in your new ride, you want to keep it on the road. You want to protect your investment, especially when diesel engine repairs can be so much more expensive than gasoline repairs. So let's head back to the shop and we'll take a look at exactly what you will be dealing with maintaining your new ride. The roots of most engine problems are friction and wear. So let's talk a little bit about how friction works inside your engine and how it will affect your truck in the long run. Here you can see we have some engine parts. We all know that motors need fuel to move, but why do they also need oil? You see, though it appears smooth to the naked eye, metal is actually very rough at the microscopic level. So when two seemingly smooth metal surfaces touch and move over one another, they don't glide nicely. They grind over each other and they shear off the peaks of those asperities. So oil's role in the system is to come between the two surfaces, pushing them apart far enough so that the peaks don't touch each other. This is important to know because up to 75% of engine wear happens at startup. These two blocks represent two metal surfaces with asperities. In your engine, there are various moving parts in contact with each other, as you know. Whether it's pistons and cylinders or the camshaft, it would be nice to think that your engine oil protects all of these parts. Unfortunately, there are a lot of things that affect the oil function, causing friction in your engine. One example is when your truck has been sitting for an extended period of time, say overnight. Much of the oil drains away from the parts it's meant to protect and separate. Then when you start your truck in the morning, it takes a second for the oil pump to circulate oil to these parts again. Until then, friction is what's happening in your engine. Don't forget, this is at the microscopic level, but it is still affecting your engine. Before your truck is started, there is boundary lubrication. There is a boundary of oil and additives, but not enough to keep the asperities from touching. Not only are the blocks hard to get moving, but the surface damage is happening in the form of scratches and markings and furrows and grooves. Once the oil pump has circulated more oil throughout the engine, the lubrication pushes the two rough surfaces apart, allowing them to move more freely. The lubrication becomes hydrodynamic, meaning the protection comes from the viscosity of the oil in motion. Now we know what we are up against microscopically. You can see where friction exists and what causes engine wear. Let's talk more in depth about metal wear. We know that wear is the removal of a material from the surface of a solid body, like we saw in the demonstration. Abrasive wear happens when a harder metal rubs against a softer metal, or it could be sand or grit involved, in which case that is called three-body wear. Imagine this happening inside your engine with your piston rings and your cylinder wall when unwanted particles enter the system like sand. You can clearly see that there is severe damage. Other things that could accelerate the wear could be corrosion of the surface or increased temperatures. One more thing to discuss is fatigue wear. If the applied load is higher than the strength of the materials, you can get small fatigue cracks. These can result in small pieces separating, and now you have even more things floating around, causing three-body wear. Your bearings are where this often can happen. Now, let's go take a look at some actual engine parts to see how this translates to the real world. We have a crankshaft that shows signs of abrasive wear. You can see an example of two-body wear here, where there's a nice even wear on the surface. You can see three-body wear anywhere you see a deep groove. That's where a piece of grit or sand or metal or something has gotten in there and really ground down into the surface. When the engine is started, hydrodynamic lubrication takes over and actually forces oil up around the crankshaft, suspending it from the bearing. Well, I hope this real-world demonstration gives you a little bit better understanding of wear and friction inside your diesel engine. And now, this week's engine segment. This is the 12-valve 5.9-liter Cummins engine. Claimed to be one of the most reliable engines, I decided it was the best engine to talk about with engine wear. The first generation of the 12-valve, also known as the 6BT, came out in 1989, with a few components that were revolutionary for its day. This model was the first pickup to be turbocharged and to employ direct fuel injection. The injectors were fully mechanical, using no electronics. All of its parts were sturdily made. For example, its forged steel connecting rods. Another reason this engine was so resistant to wear was that in 1991 an intercooler was added, increasing the amount of air able to be compressed and thus power created. One problem with this engine was the revolution limit, which was only 2,500 RPM. This forced you to be constantly shifting, making driving pretty annoying. The second generation of the 12-valve ran from 1994 to 1998. A few upgrades were made on this model, including a larger intercooler and a waste-gated turbocharger. The biggest upgrade was in the injector pump from first to second generation. The Bosch VE44 mechanical injection pump, or VE pump, was first generation, comprised of a single piston pump. But the VE pump is known to have seal issues and doesn't respond well to modifications. The Bosch P7100P pump has multiple pistons, one for every cylinder. Better fuel injection means more power, and this pump doesn't die. It also has the ability to be upgraded in almost every way, to the point that second generation Cummins with P pumps are prized drag racing engines, with modifications available. So overall, this truck is very durable and is not highly susceptible to wear. So, just to recap, at a microscopic level, metal has asperities that cause different types of wear: 2-body wear and 3-body wear. So what now? This sounds really detrimental in the long run to a diesel engine, your diesel engine. Is there anything that can be done to prevent friction and wear? Well, stay tuned to our future episodes to find out. Send the topics you would like us to cover on a future show to video@hotshotsecret.com and we might put your idea in an episode. Thanks for watching, and we'll see you next time on Fuel Your Mind.